Hello guys, my name is Diego Pacheco and this is gonna be a slide cast. Some time ago, I made two slide casts about management non-obvious, and today I will continue doing the non-obvious series, but now this will be a slide cast about architecture and engineering. And my goal is also to recommend books. So there were gonna be 20 books that I'm recommending, but also some of these ideas, not necessarily all of the ideas, you will find on the books. So, but several things you definitely gonna find on the book, but this deviates a bit from the management one, where like more things were on the books, and now not necessarily everything is there, but these are things I believe, and you can find these ideas on the internet as well, right? So they're not necessarily my ideas are unique, right? But I just want to give this disclaimer that you might not find everything on the books, but I'm gonna recommend some books that definitely aligned with the ideas that I'm gonna show here, and hopefully you guys can get some insights about what I'm gonna present, right? So without further ado, let's get started about architecture and engineering, doing the non-obvious. Okay, so the first thing I want to tackle about and talk about and tackle is about requirements, right? We have this vision that requirements is something holy, that's something sacred, that's something we should not question, right? And in reality, requirements, when you have a list of requirements, it's just a list that somebody made, right? And oftentimes that list is really bad. It's not even a requirement, it's a decision someone made, right? And that's a very lean idea. Lean believes a lot that requirements is just somebody else decision, right? And it's just decisions, and sometimes they're not even decisions, are features. Other times are like technical depths. Other times are goals. Other times are sort of short-term objectives or projects. So it's a mess, right? Sometimes I see a requirement list is everything but a requirement list. But the thing is that we need to understand there's no such a thing as requirement list, or requirements doesn't matter, right? Because that's just a decision that somebody made, right? What really matters is that you understand the nature of the problem you want to fix. You understand, and you are being driven by principles, and you have goals, and you have a clear strategy, and you communicate well how you're gonna do that, and that's what matters. Not requirements, not a list of requirements, and requirements are lies, right? And that's a very lean idea. Lean really believes that requirements are lies. So do I. I really don't believe in requirements. Most of times, requirements lists are useless, right? So do not spend much time with requirement lists. Instead, try to capture the crux of the problem that you are dealing with. Try to capture the goals you want to have. Try to capture your strategy. Trade-offs are often a good idea, right? And thinking different solutions and different approaches, but try not, write a requirement list. Oh, there is a requirement list, just let's follow that list, right? Because that's really doesn't work, and that's really a bad idea. All right. The next one is, and that's you might found these ideas around XP folks, right? So thinking or even typing are not bottlenecks. The real bottleneck is migrations, all right? Migrations are bottlenecks. Think about something, design something up to front or not. Engineering something is easy. The hard part is migrating it. Like going to all your customers and migrate their code to use what you built. Of course, depending how you deliver and how you distribute software, meaning do you have a platform, or do you have a service, or do you have an infrastructure, you have a sidecar. This can be more transparent. However, the more this is close to an application framework or a library, it worse it gets, right? Even for services, you might have some migration. Let's say you're introducing a new API in your service, or you have a driver, now you have a new operation there, or whatever. So there are always gonna be migrations, but for sure, libraries are really bad, right? Like that's really where you're gonna get the cost, and that's where you're gonna disrupt multiple teams. And the more libraries you have, the bigger is your company, the worse this it became, right? So stop worrying too much about typing or thinking, and start thinking more about migrations. That's where you want to actually optimize things, and you want to do things in a clever way. And that's why it maybe is a good idea to not do libraries all the time, right? And maybe thinking about like programs that can do migration, or automating migrations and stuff like that. Okay. So the next thing is, and you will need to take some time to swallow that one. You might not swallow at all, that's fine. But we have this hardwire in our brains as engineers that we believe is profane, is unholy, is wrong to duplicate code. And actually is the other way around. The things that work, they work it based on duplication. Distributed systems are about fault tolerance, they are about anti-fragility, and in other words, this means duplication, right? So NoSQL databases are about duplication, distributed systems are about duplication. When you talk about a high available system, we often are talking about at least 3 instances, right? So that's duplication, right? So duplication is fine. Shared libraries are not fine. When you have shared libraries, you have third-party dependencies, and 99% of the times engineers and architects do not pay attention on the shared libraries they introduce on people class path, and it doesn't take long for you to kill all your microservices benefit because you have a distributed monolith and you have binary coupling level 100, meaning everything you do, either you do to all your microservices, I don't know, 100, 200, 2000, 10,000 microservices, and that's really bad, right? Because kills organically migration, it kills your ability to do things in isolation, and it defeats the purpose of microservice. The idea of microservices is to have isolation so teams can innovate in different times, right? And independently. But now, if you need to force everybody to change things at the same time, well, you just kill your microservice, all right? So really, there's no point to have microservice if you have more shared libraries than services. That's really gonna kill you, all right? If it didn't kill you, think it twice, paying attention, really pay attention if it's really not killing you already. If it's not, just wait. Eventually, this will kill you, all right? There's a very interesting video on the internet about Netflix experiences building Netflix OSS and how this affected them, right? And that's the story of the industry, right? Several places I worked, pretty much all places I worked, had this issue, right? Of I don't want to duplicate code, they're going to create shadow libraries, and that becomes, it take over the microservices and you kill all your benefit, right? So that's really a bad idea. If you really need to do a shadow library, be careful. Think twice. Think if you cannot do a service. Think if you cannot generate code. Think if you cannot make a platform. And if you still really need to make a shadow library, make sure it's lean. Make sure it doesn't introduce dependencies. And let me tell you this, you need less things you think you need, and code duplication is fine. If all your 3,000 microservices, 10,000 microservices, they have duplicated code, that's fine. Okay. Now, The next one is tests do not find bugs, and tests do not improve the design, right? So that's two birds with one stone. So tests do not find bug. Let that sink for a moment. Why tests do not find bug? Because to find a bug, you kind of need to predict that you're gonna have the bug. So this is all about our ability to predict bugs. And if the bug was there, it's not like you are finding bugs, right? So you're just showing the presence of bugs. So tests, they cannot show the absence of bugs. They can only show that they didn't found that specific things you are testing. And think about that for a moment. I'm not saying you shouldn't test. That's not what I'm saying at all. You should be testing, but we need to acknowledge a couple things. So let's say, oh, okay, I have a test, I test 3 things. It means you have 3 chances to find an issue. But are you sure you capture all failure modes? Are you sure that's all the things that could happen? All right? And tests are about confidence, and often what happens, we just write tests for the happy cases, and that does not protect us from bugs, right? So we need to understand that tests will not find bugs. They only will show us the issues that are already there, and really limited for the number of tests that we make. If we don't make it a greater coverage, right, we really will not be covered, because again, tests do not show absence of bugs, only the presence of the ones we coded, right? That's why there's this thing called mutation testing, which I like it a lot, which tests your tests and then can tell you if your tests are missing bugs, right? And that's something you really want to consider. And the second thing there is that tests have limits, because you need to predict that something gonna happen. You need to think it, okay, so if I have like a method where I'm passing a string, I might need to pass null, right? So I thought about that beforehand, then I can write a test. So it's all about replicating failure modes. And what happens is, in the distributed systems and in the cloud, is really hard to replicate production and replicate failure modes. So there's limits of tests. And sometimes it's really hard to test all the things. It's better to work with anti-fragility and then be able to recover from bugs and have isolation, right? Bulkheading and so many other things on that direction. And finally, what I said, that tests do not improve the design, right? Because the design is not tactical question, is a strategical question, and design is about the whole, it's not about features. Features do not improve the design. Thinking strategically, that improves the design. So doing tests will not improve your design, right? It only work in a very basic level, like, oh, I have a method that receives 0 parameters and is void and does a bunch of things. Of course, for that kind of stuff, your TDD, your test will gonna get it. But if you are passing things and returning things, your test is gonna have a very low bar for improving your design, only for the most basic things, right? So for senior and principal engineers, for folks that have more experience, TDD or test first will not really help you much, or even testing, right? Like traditional testing might have lots of limits, right? And again, like I said, in production, it's much better to be able to recover things and to isolate failure rather than think about all sort of failure modes, right? Because it's impossible to think about all failure modes, right? So tests do not find bugs, tests do not prove the absence of bugs, and tests do not improve your design at all, right? That only works for junior programmers. Now, the next one is bugs are clustered together. So there's always hotspots of bugs, right? And again, tests has limits, right? So that's our very interesting things, right? So on the previous slide was already kind of a tackling on this idea of limits, right? Because pretty much the good your tests are, as good as your predictions are, and our prediction sucks. Our ability to estimate things sucks, right? So, but there's something you can use in your favor, right? Like we have better ability to explain past events. So there is this book called Code as a Crime Scene where they did some research, and they found out that often bugs are clustered, and often changes are clustered. So if you start to see it, your code base as a city, and you imagine a class that has lots of commits as a building. So if you have 1 or 10 commits, let's say is one store floor. If it's 100, it's 2, 300, it's 3, and so on, right? So if we sort of visualize our code like that, the classes that has lots of commits, probably they are sort of Empire State buildings. They are like super huge, right? And will be very skyscrapers, like pretty high buildings. And that's the ones we want to watch, right? Because bugs tends to be on the places that we are changing very often, all right? So bugs are clustered together, all right? And that can give you a lot of insight where we might introduce the bug. All right, so that's something you actually can rely on. The next one, right, and for sure this is going to be very controversial. I'm sure the other ones might be really controversial for you as well. But non-orthogonal systems require big design up to front, and I want to clarify a bunch of things here, right? So in XP, Kent Beck often said that you don't want to do big design up the front. But I would say that's not necessarily true, all right? And we need to even go deeper on Kent Beck comment, right? When he say don't want to do big design up to front, keep in mind there's the word big there, meaning it doesn't mean you not want to do design up to front. You need to do design up to front, but you want to avoid big. But I go even further. Well, you don't want to do big design up to front when you have orthogonal system, meaning in math, orthogonality means you have like something like it, like here, stuff that's parallel, right? That it doesn't touch each other, means is isolated. So if you have a system that's orthogonal, meaning it doesn't affect other systems, is enough isolation there, then you should be completely fine. Like you think about SOA, where you have your contract and you have your implementation, and your implementation can be completely orthogonal if you don't use shared libraries and you don't have 300 shared libraries, right? Or 100 is enough to make damage. Even 10 could be enough to make damage. But if you have like your implementation in SOA and that's isolated, it means that's orthogonal, right? So if it's orthogonal, it means, well, you can do things there under the hood and will not affect others. And that's great, right? So for that reason, you don't need to worry too much about design, because you can improve the design after the fact and you're going to be able to have factor without affecting others. However, if you're dealing with something that's not orthogonal, and if you change something going to affect others, you really want to be careful about that, right? And if you get the wrong design, that will be really problematic, right? Imagine like you have a contract in a service that there's 1,000 of services using that contract, and then you keep changing the design of that contract over and over. It means 100 time migrations each time you do that, right? So 3 times will be, it's like going to 3,000 services, right? Or 1,000 3 times, right? So it's really, really bad. And it's gonna create so many problems. So for that cases, when you don't have orthogonal system, you really wanna go anti-agile. You really wanna do big design up to front, because if you mess that up, the cost of change gonna kill you. All right, you really don't wanna do that. So be careful. All right, you need to watch if you are dealing with orthogonal system or not. If you're not dealing with orthogonal system, you really want to do big design to front. And to give you an example, like security, right? Security often is not orthogonal, right? And sometimes you have different aspects. So you change one thing here, you think you're changing isolation, you're not. So one thing is affecting another, all right? So watch for that. When you have non-orthogonal systems, doing a big design to front is the right thing to do. And one example of that's like building a boat, right? A boat is not different things. It's like the inshore and the boat are separate things. So it's all one thing, right? And one thing can affect the other, right? Like say if the inshore is too big, too heavy, you might pull the boat down, right? And if like the boat is not well shaped, it might sink. So really what happens is like, you need to understand that this is one thing, is not multiple things. Even if you can do pieces in isolation, and even in some level of parallelism, right, it's really hard to parallelize, and at the end is one thing. This is not like three different components, right? It's one component, right? So you actually need to be a bit more waterfall here, and you really don't want to make things that parallel, right? And you want to make understand that if you change one thing, gonna affect the whole system. The whole system is not orthogonal, right? It's one tight thing, and just think about that. Understand there's no silver bullet. Sometimes some systems are orthogonal. It's fine to relax on design. Other systems are not. You need to go more heavy on design. Okay. So the next one is that architecture is about people and teams. And often I just see architects concerned with technology or just understanding technologies. And architects need to understand technology, but they need to understand teams. They need to understand people because it's all the same thing, right? This is like on the boat where the anchor, but you don't know the other parts of the boat, right? You'll not be able to do an outstanding job. So you need to know the whole thing, right? In order to know the whole thing, you need to understand about people and technology, people and teams. And with that, there is this old thing called Conway's Law that says that the structure of the software will mirror the structure of the organization. For instance, if you have small distributed teams, more likely you're going to have modular service architecture, right? With small bounded context services. If you had large collocated teams, you're probably going to have a monolithic architecture, right? So the Conway's Law pretty much is saying like, if you have things clustered together, you're going to have low entropy and you're going to have some sort of order. If you have, things kind of a spread, you're going to have high entropy and you have some disorder, right? So you definitely want to have some sort of a balance here because I personally believe you want to do services a bit more fat, but per domain. And then inside of a domain is a bit fat, but outside of a domain, you have more domains. I don't think you should have like one monorepo, but you might have like one monorepo per domain, for instance. That's fine for me. And I really want to watch about this because we do this without thinking. And we need to think if the decisions that we are doing in our technology is because of the team we have, the people we have, the deadlines we have, the constraints we have, right? And that can be focus can be a double-edged sword, right? Where it can really get us as top performers and get things done, but also can blind us pretty heavily, right? And we can be pretty blind. And that's something we need to keep in mind, right? That sometimes we need to change the organization, how we organize people, and sometimes we just need to fight that and say, no, just because I have this thing, it doesn't mean I'm gonna do it this way, right? So this is super important, and we often don't think about it, and architecture is just a result of how we organize. The next one is that complexity needs to live somewhere, all right? And abstractions, sometimes they make things more complex than it needs to be. So we have this sort of obsession with types, with type systems, with generics of generics, higher kinded types, and shortcuts in type systems and stuff like that. And sometimes, right, having something which is completely dumb, right, and specific is 10 times, 100 times easier than trying to make something generic and abstract, right? And it's okay to have complexity living in somewhere, right? We kind of forget this idea that we should have zero complexity, and that's impossible. And that's how we create complexity. We create complexity because we don't want to have complexity, and then we complicated things because we're trying to get out of complexity. But it is what it is. There's two kinds of complexity, right? There's like the natural complexity of the domain, right? And there is the overhead of complexity that we often introduce in things, right? But there is some threshold of complexity that you never can get rid of it. And if you try to get rid of it, you're gonna make it worse. Right? You're gonna make it worse. You're not gonna make it better. You're definitely gonna make it worse. So you need to watch it about this idea that always abstracting things, abstractions has a price, right? And it's okay to have a complexity living somewhere, often downstairs, right? Often close to the core of your system, right? So basically, that's something you need to wait in instead of always trying to create abstractions, right? Okay. The next one is about estimations, right? I personally don't believe in estimations. I don't believe in requirements. Why would I believe in estimations, right? So I don't believe in estimates. However, oftentimes we need to have some sort of grasping ballpark about what we are dealing with. And that's very limited and often wrong by several orders of magnitude, but that's a way to sort of do some sort of a prioritization, right? Oh, should we do this project or that one? And then for that, we need to have some idea what we are dealing with, right? Even to do it or not do it, or even to prioritize, get more resources or whatever. So this whole thing is flaw, right? So I will not spend much time saying it's flaw because it's flaw, but what you can do to make it less flawed, right, is to do this. So let's say we have this field with all these ships, right? And what we need to do is calculate how much food we need to buy for the ships, right? So you can wildly guess, how many ships do we have. We can do planning poker with the team and stuff like that. But it's better to be based in facts, right? So the best thing you could do is, okay, have we ever counted these ships? Did someone count them before? If someone do that, go talk to that person, right? Because that will gonna be your most valuable parameter in sense of location here. If not, okay, so I don't have past data that I can look on. But maybe, okay, nobody counted the ships, but maybe someone counted, horses, and we have similar number of horses and ships, So there's other things you could look to sort of give you one parameter, right? But let's say you don't have that. Well, then what you should do is counting things. Okay, let's count the number of ships, then we can sort of create average amount of food that a ship might eat, and then we might have something that's reasonable, ballpark, right? And then you have this trinity of I'm gonna count, I'm gonna analyze, and instead of giving one shot, I'm gonna give ranges, right? So I can say worst case scenario, best case scenario, and middle ground. So instead of giving one estimate, you can give 3 estimates, right? And I want to be clear, I'm not defending estimates. I totally believe in no estimates. I think we need to reduce the number of estimates. I don't think they are reliable at all. But unfortunately, sometimes we need to do it. And when you need to do it, if you really need to do it, all right, because most of times you also might find a different way to deal with the problem. But if you need to go there, right, you want to have past data. If you don't have that, you want to count, you want to analyze, and you want to do ranges, right? You do the worst, the best, and the average, right? And that at least will minimize some of the problems. It still will not be perfect, right? But it will make less worse, right? I would say the less of the evils. The next one I want to talk about is about long term. All right, as the time passes, software and teams, they have erosion. All right, especially teams have erosion, even because your teams come and go, like your people move to different companies, you hire, you fire, or your business changes and kind of innovate and stop offering some services and now offer different services. Your business kind of reinvent itself. So erosion is a thing on teams, and the more the time passes, the more erosion you get. That's something really common, especially if you are highly innovating and experimenting with things, right? So if you're doing lots of discovery and your company is heavy on startup mindset, you're gonna be assembling and destroying teams all the time, right? But that will create some scenarios, like scenario where sometimes you completely don't need that pieces of software, and other times, well, just because you lose the team, it doesn't mean that even the new team cannot use that piece of software, right? So sometimes the software can be a bit more generic and can kind of survive different teams, or part of the foundation can survive. You might still want to have factor, right? But I want to say is like we have this effect of thin erosion, all right? And because of that, we should have ownership and catalogs, right? We should be able to know who owns what, right? Because we will need to do migrations. And with that, I went into Discover, right? I really like this idea of data meshes on the big data and data science landscape, where they pretty much go on the idea of you should have dynamic registry and catalogs for everything, for all data assets. And I totally believe on that idea, like deployment data, database data, services data, code resources like GitHub, infrastructure resources like Lambdas, buckets, Kafka streams, and so on. And you want to have owners for all these assets, because then you can easily calculate the cost. You can easily, in case of migrations, you can know who is the responsible for that. And you can also have discovery, so you can have software. So if you need to operate in all these resources, you can do that dynamically, right? So Netflix, some time ago, on the Netflix OSS, had a piece of software called Eureka. And Eureka used to do service registry and discovery for microservices. And then you have these places where you know where all microservices are, and you can easily discover the IP and son of metadata and call them, all right? And that is quite useful. But I would say that same idea, it should be for all the technical assets, not only services, but databases, Lambda, and you name it, right? So that's why we need to be aware about the thin erosion effect, and we want to fight that with owners for everything, catalogs for everything, and score for everything. Sorry. So this is for this slide. The next one, it will be about how we tackle debit, right? And I believe we all tackle debit on the wrong way, right? Because one thing we do, we're always trying to tackle the debit instead of trying to tackle the source of the debit, all right? And for me, there's two sources of the debit that we often don't tackle. And what's the problem by tackling the debt directly? It is, yes, that's great. You fix the problem, but you didn't fix on the source, so it will happen again. All right. And I mean, the source of the debit for me is two things. One is totally related to education and your talent pool, right? So if you have like great engineers, or you're training your folks to be great, that's one thing that it either gonna be a source of great solutions or a source of debit. And the other thing is about time, right? There's one effect that happens with teams, that we often have the teams on operating on 100% capacity. And if your teams are 100% capacity, you really don't have spaces to make mistakes, right? And the problem is that for estimates, we always make mistakes. And then we are already 100%, and then we need to do an extra mile because our estimates are wrong, right? And then we already are in a problem, right? Because now we need to give 100% or 150% just to deliver what we promised, because we underestimated, right? Or we are trying to push aggressive deadline. That often is the case. But what happens if there's bugs? Well, bugs was not estimated. So now what you need to do, 200%, 300%. And not only bugs, but technical debt happens. Okay, now we really don't have times because our estimate is bigger than we thought. And, there is an aggressive deadline, and we have bugs, and how I'm supposed to improve this code? I don't have time even to deliver the features on time, right? And that's why you are in a position where you just create bugs, right? So feature factories are bug and debit factories, right? And Great if you have a talent pool or you invest enough in education, but that will not be enough, right? You also need to fix the capacity problem, and that's a very Kanban idea. So what you want to have is Slack, right? And Slack is not, I'm not talking about ERC or chatting, right? Slack is a word which means reserved capacity, right? So you want to have reserved capacity. And if you have reserved capacity, let's say in your next planning session, you only estimate 60% or 70% of your time, right? So in that case, let's say if you do 70, right? So, okay, so I have 10% buffer for bugs. I have 10% buffer for our own estimates, right? If in the case we want to deliver features, or if the scope grows, if there's some scope creep, we also have 10% for that. And we also have 10% for technical debits, all right? So you actually have time to do maneuver. You have a runaway, and then you can accommodate things. So it's really, really important to not be 100% busy. But we have this management thought that, oh, if you want to take the best out of our engineers, they need to be busy all the time, right? So you don't want to be busy all the time. That will just gonna pile up problems, right? So if you are less busy, you still can deliver, all right, and we still can improve things at the same time, all right? So that's really killing debt at the source. Is these two things, is working on the education and talent pool, and is also have this Slack reserved time for improvements in technical depth, testing, security, observability, automation, your own estimates, whatever, right? So that's what I have for today. This was the first series about architecture and engineering, non-obvious, and here are the books. So we have like Pragmatic Programmer. This book is really great if you are starting on the field. There's Architecture Bootcamp. If you want to be an architect, you really should read this book. This was one of the first books I read about architecture. It's really good. Software estimation, all right? If you need to do estimation, this is the book for you from Steve McConnell. It's a really good one. Philosophy of Software Design, that's talk about modern design concepts, really, really good. XUnit test patterns, how we can do proper testing and the difference between like mocks and stubs and spies and test doubles and on and on. Drift into Failure, a really awesome book about anti-fragility, chaos engineering, and non-obvious management. Slack, as the name says, right? Another killer book about having reserved time. Have Factoring, really good one. Code as a Crime Scene, that's gonna help you with this better testing mentality. Germ, Just Enough Requirements Management, right? Some book about requirements is a good one. Loom Shots, which talks about very crazy and very different ideas about discovery and delivery, pretty cool. This book, which is an engineering manager, talks about like engineering manager things at scale. The Myth, Calm, and Mouth, that also talks about variability, lean, the difference between dev and ops. DevOps Handbook, awesome book about lean and modern techniques to do proper operations. XP Explained, a book about extreme programming. Lean Architecture, Design, Thinking Systems is system thinking. It's not to do with design thinking. It's system thinking. Is something much more old and really good. All right, so you start to see complexity and start to think proper about connections of things and the cost of complexity and so on and on. So this book is really, really good. Building Microservice, right, is a new book, modern book about SOA and services. Enterprise integration patterns, about how we integrate software. And if you think this is dated, keep in mind that we have lambdas now, right? So this perfectly fits what we're doing for lambdas nowadays. And Implementation Patterns, a book about programming and code patterns, right, by Kent Beck, good book as well. So that is the first slidecast about architecture and engineering, doing the non-obvious. I hope you guys like it. See you next time. Take care. Cheers.